Your facility is alive. It is a moving, breathing collection of parts, processes, and people. And with so many dynamic factors involved in food production, a deep, data-driven understanding of how they all interact can make the difference between a thriving, productive business and a stagnant, inefficient one. Introducing Predictive Diagnostics, a suite of solutions from bioMérieux that integrates traditional microbiology tools with data science, sequencing applications, and predictive modeling to data mine the microbiome of your facility and products. It allows for analyzation of supplier and raw material risks, environmental monitoring, finished product variances, factory performance, and even customer complaints, and helps to distill a mountain of data into real-time, actionable insights. This precise, data-driven approach enables food quality and safety teams to move from detecting and responding to situations to predicting and preventing contamination, reducing hold times, and minimize recalls. It's a new way of improving food quality, safety, transparency, and company profitability. Predictive Diagnostics from bioMérieux. See the future.
For over 55 years, you've trusted bioMérieux to provide state-of-the-art microbiology solutions to enable the industry to detect and respond to food safety and quality risks. Today, we are proud to introduce Predictive Diagnostics, a new way of improving quality, safety, and profitability for your operations by predicting and preventing problems before they occur. With me today are three renowned scientific leaders who, along with a full cross-functional team, are leading the charge with our customers to revolutionize the way we collect, analyze, and apply the vast ecosystem of data across the supply chain. Bioinformatics and data science expert and the mind behind CDC's PulseNet, Dr. Hannes Puseli. CEO, scientific innovator, and entrepreneur, Dr. Nick Siciliano. And inventor, diagnostician, and renowned molecular biologist, Dr. Vic Dutta. Let's explore this new frontier and understand how predictive diagnostics will change the way we ask questions and solve problems. So Vic, I'd like to start with you today. Through the lens of predictive diagnostics mindset, how does this change the way that we, the industry, think and behave? How do traditional core microbiology lab solutions marry with this new concept?
The traditional microbiology is sort of a very 19th century concept we carried into 20th century. It was always meant to sort of help us, the human beings, fortify our efforts. And we have done that well as bioMérieux, as a company. This is something we know very well. We know how to do this. We've been very much part of this as the Industrial Revolution took hold. Fast forward, we are now in the age of data. The data revolution, and how do we utilize the information is more critical than how we collect information. So at bioMérieux, we have been building diagnostic solutions, marrying different technologies over many decades now. The common theme so far has been that the problem statement has been defined for us. Think about salmonella testing, think about your yeast and mold testing. We know what our customers want and need, and therefore we just bring in the technology and give them the solutions to at least help them getting close to solving the problem, because to solving the problem starts with knowing that there is a problem first. With the data revolution happening under the surface, and we are all sort of living through it, we are asking ourselves the same question, but in a different way. We have the technology, we have the people, we have the minds to look at the problem and come up with the best solution. What we need our customers to tell us is what the problems are. We need these problem statements so we can put the right technology, the best minds, and come up with the right solution for our customers. And all of that requires not just the problem statement that is defined by our customers on a day-to-day basis, but it also takes into account different regulatory components, different aspects of the industry. We club industry as manufacturers, but that's not true. We are very much part of the industry. So are the regulators and the consumer groups and the different lobby groups that influence how industry comes together and solve the problems. So all of this has to come together. And that's where we think we can add value, because we are in a very unique place. We are the widget makers. We can translate the problem statement and come up with solutions that actually make sense, and at the same time help our customer meet the regulatory requirements. At the same time, we should also be able to work with the regulators as they are continuing to evolve their mindset, their strategies, their ideas about what the world would look like through next decade or so. We can help them get there, because again, we sit at the crossroads of technology and solutions. And at the end of the day, what we need to do together is define that problem, and we can help our industry partners get there. And that's where predictive diagnostics come in. As a concept, as an idea, it's a very powerful way of looking at things. You're not just looking at your result in a right now basis, but you're able to look into the future, which in the essence is what we wanted to do all along. This just gives us another oomph, if I may say it, in that direction.
Hannes, you've been solving problems with data your entire career. Can you explain the unique ways that bioinformatics applications and diverse data streams can be applied to promote a healthy factory with predictive diagnostics?
Yeah, I think we're at a time where we have collected many single data points and taken daily decisions on just one test, one data point. And I think now we're in a situation where we've collected enough data to start doing something more than that. I always think, well, once we have a data point, let's keep it for future use. It might be handy at some point. So, and that's exactly what we're trying to do. What we're trying to follow the data and trying to unravel the structures that are behind it by not just looking at one data point, one decision in time, but at how things tie together. And by following the data, by being intentionally naive, I try to bring a viewpoint that gives you a different perspective on a problem. Sometimes that gives us the opportunity to narrow down the box around the problem, understand better where the causes are, and really try to get to the root of something. But sometimes the data just doesn't provide us anything more than association. But that's okay. I mean, association is good. We can work with that. I mean, just think about a real life example. I mean, if you come home from work, you have a huge headache. What do? You say, well, I've got a headache. It just happens every now and then. So you take a painkiller and just move on. But at some point, if that happens a few times, you're going to start asking the question, so where is it coming from? Maybe the causes are unclear or just things that you can't control, but at least you'll get a sense for when is it happening, under what circumstances, so that gives you a way to somehow see it coming, see the risk, and mitigate the risk up front. And this is exactly the same what you're doing if you're thinking about factory health, if you're thinking about in environmental monitoring, for instance. Imagine you're producing mozzarella cheese, and every now and then your cheese goes blue. So what's going on? You could say, well, we see the cheese goes blue, we throw a lot away and start over again. So that's just one data point. But if you look at the data points as a whole, and you look at everything that happened over, say, a year or 2 years or 3 years of data, then you'll start to realize that maybe it's always or mostly happening on a Monday. And it's happening on Mondays after it's been raining for 4 days. So that's a completely different understanding. It doesn't help you understand the cause of things, but it helps you enormously in controlling and mitigating the problem. So it's not just a point observation. It takes you all to the point where you narrow down the box and you can start solving the problem, or at least controlling the problem without actually being able to solve it. Now, the problem in many of those questions is that the human mind is not very well suited to do these things. There are just too many variables. There's too many dimensions. And you really need to use the data science approaches to put these things together. So even in other cases, exactly the same thing. Think about raw materials, right? I mean, you've got a bag of cocoa coming in, and there's a problem with it. Okay, so how can you be prepared for these kinds of events? Can you somehow estimate the risk that the next bag of cocoa is going to be a problem? Turns out you can. But in those situations, it's not just about, well, we've had a problem last week, so we're going to have a problem again. It's much more complicated than that. It has to do with contracts and when you make them, and it has to do with putting all the products at the same level, but it also has to do with labor strikes in Brazil. Because maybe you're buying walnuts from Brazil and your walnut supplier just has unhappy people working there, which is going to be a bigger risk on your product than if they would just be merrily, happily putting walnuts in a box. So there's a lot of different factors that come in together, and that you somehow need to be able to compose, and that's exactly where data science helps in exploring scenarios without being focused on a hypothesis, but being able to follow the data and see where that leads you, and see how that can be applied and helpful in your situation. So sometimes it's not really about the data science that helps you out at the end of the day. Sometimes we realize that we got to go back to the good old microbiology in the newest form. So we go sequencing stuff, and we ask ourselves the question: so if you've got a resident pathogen, so why is it there? Why can't you get rid of it? And then very quickly you end up with questions around biocide and biofilm, and that sequencing can start help answering those questions. So, or it's about the spoilage phenotype, where you really ask the question, so if we understand bioinformatically what's going on, then how do we somehow create something that helps us? Because sequencing everything that comes through the door might not be convenient. So then you're really thinking about, how can we create a simple test, something easy that's based on all this knowledge behind it from bioinformatics and data science that helps us control the problem. And that takes us back to very traditional microbiology and traditional testing, at least in my crooked mind, where you're really asking the question of, can we do something concretely next to the line that helps us control the problem? So to me, the marriage between, let's say, food manufacturing, data science, and microbiology goes in all three directions. I think it's really cross-fertilizing what we're doing here.
Nick, the Invisible Sentinel team is really an integral part of the predictive diagnostics aspiration. How are you and your group working with the industry at large, as well as our internal teams here at bioMérieux, to deliver new era solutions for these age-old problems?
So here in Philadelphia, we're building the Predictive Diagnostic Innovation Center, which is intended to be the brick and mortar embodiment of a global collaboration between our scientific teams here at bioMérieux. And our mission is to bring our scientific teams together with our industrial partners and academic collaborators to use new generation tools like next generation sequencing, data science, to build better solutions, diagnostics, services that add value to our customer base. And that will allow them to get ahead or predict risk, predict problems, instead of simply just reacting to them. So as a scientist, I've always enjoyed translational research, taking a project from the discovery phase all the way through to creating a new solution. And these are the types of projects that we aspire to take on here at the Predictive Diagnostic Innovation Center. And one example of a recent project that we did is with Body Armor. Body Armor is a fast-growing sports drink company that was interested in doing a discovery-based project to look at what microorganisms were associated with their raw materials, their manufacturing processes, and ultimately their finished products. And of those specific microorganisms, which ones were capable of causing spoilage events. So, initially it was a discovery-based project where we incorporated tools like next-generation sequencing and bioinformatics to determine, what microorganisms we were able to find. We then took the next step and looked at and did an assessment to see which of those microorganisms were able to spoil the product or were quality or safety concerns. And then from there, we were ultimately able to build them a new multiplex diagnostic that they're able to implement at their production sites to test their raw materials, to do their environmental monitoring, and to ultimately test their finished product. So, these are the types of projects that, again, we're looking to do here. Everything from taking that initial discovery and putting our tools and our team's expertise to work, to then at the end of the day, delivering a tangible solution to our customers that adds value to their operation.
On the back of the FDA's new blueprint for smarter food safety and similar regulatory evolutions that are beginning around the world that are pointing to the need for smarter, people-led, tech-enabled food safety, why is predictive diagnostics so important in this fight to bend the curve of foodborne illness?
Well, I think what we all aspire from a food safety standpoint is to really prevent outbreaks. I mean, obviously, we want to be able to be reactive and identify the sources from a traceability standpoint, but I think the overarching goal is to ensure that these types of things don't happen, right? That's ultimately what's going to protect the consumers and protect our customers from any associated risks of recalls and obviously, contributing to, a potential health problem for the public. So I think that at bioMérieux, we've spent a lot of time kind of building this toolbox where we are able to incorporate our different technology platforms, the scientific talent that we have, the bioinformatics, to build new tools to really get ahead of the curve. We've been working on this for a while, and now with the FDA's new initiative, I think the timing is critical, and it's time to put this toolbox to work. So that's what we're intending to do, and that's really the initiative in building the Predictive Diagnostics Center and really kind of getting out front, is really leveraging the toolbox that we spent years building, the technologies that we have basically integrated into our innovation suite, and being able to develop new tools for the industry.
So I would like to give a more technology, a very fundamental, basic reason why we think that this is the new trend. And when I say we, I mean food safety professionals, including the ones you're referring to at the FDA. This is a sort of ongoing revolution that we are in the midst of, and food safety is just getting exposed to it. What I mean by that is, we as humanity have seen the computer science, the data science take over our lives. We're talking right now digitally. I mean, we know this, we can all relate to it. And this is happening because of the revolution that is happening on the microchip world. And that is allowing us to process things faster, to store larger amount of data, to just think through algorithms, more complex algorithms, in a more effective way. So what is this leading to in where we stand today is what I would like to categorize as a prediction business. Food safety is one aspect of it, but you can look around, it is happening all around us. I like to talk about the cardiogram app that is on Apple Watches and how it's able to do a good job with prediction of heart diseases, right? It's feasible today to be able to do it. 20 years ago, maybe not so much. And part of the reason is that the sensors are smart, and we have the cloud capabilities. We have the ability to store the data, process the data, and just go with it. And there's another sort of component that is brewing under the surface here, which is, and again, Hannes can speak to this much better, but the way we are learning, the things we are learning about data analytics, what we are realizing is that certain events, by association, strongly associate with certain, with something like a symptom. And the association of the data points to certain events defines how much data we need to be collecting. In other words, if there is a strong association, it is being found now that you don't need to collect a lot of data. And that becomes powerful because as you start building the prediction models around something to sort of look into that event, you may realize that because of the strong association, you don't need a whole lot of data. And that sort of takes me back to the traditional microbiology and makes me think the way Hannes was referring to earlier. We have been collecting these data points. In fact, food safety professionals are probably most sort of voraciously collecting data for many, many, many decades now. We just haven't ever looked at these data points as together, as one entity. And now we are able to do that because we have the tools, we have the means. So this is not just going to be a desire anymore or aspiration, but this is going to be the direction we are going to take as humanity because it adds more value to what we do on a day-to-day basis.
Yeah, I tend to agree with you, Vic. I think we are in a unique time where we can start taking some of the randomness out of the events that seem to happen to us. If you think about pathogen contamination in a product, you can think of it as something that happens to you and you have no control over it. But actually, what we're starting to see is that these processes are not just random things. pathogens just don't happily turn up at some day in your factory and go contaminate your product. There's a systemic after it, and it's hard to unveil because there's many factors impacting at the same time. But I think data science is exactly there to help the human brain to comprehend what is going on, and at least take some part of the randomness out of the events that we see. Now, I think it's not just about foodborne illness, though. It's also about quality. It's also about spoilage and shelf life, because I think those are the key areas that will be very important for food manufacturers to improve their productivity and to produce more food. It's not just about things that make us sick. It's also about the quality of the product.
Thank you for joining us to meet some of the pioneering minds behind predictive diagnostics. To learn more, please visit predictive-diagnostics.com. See the future.